One. Hi, everyone, and welcome to today's webinar. We're super excited to have you all here. This is a webinar series where we're introducing and explaining some of the interesting open source projects that stem from VMware. And the topic of today is a project called vSphere Integrated Containers with a focus on the vSphere Integrated Container Engine. If you have any questions throughout the webinar, please add them to the Q&A at the bottom of your Zoom client, and we will answer them there throughout the presentation. Our speaker today is Patrick Daigle. Patrick has been with VMware for 11 years, which is a long time, so he's a veteran at VMware. He's been focused on cloud-native applications for over 4 years and working on Vic, the vSphere Integrated Containers, and related open source projects for the past 2 years. With that, I'm going to hand it over to Patrick, who will start his presentation.
All right, thank you, Jonas. So welcome, everybody. We're going to spend the next hour talking about vSphere Integrated Containers. So as an agenda for today, I will first talk briefly, give an overview of the different open source initiatives that we have in the Cloud Native Applications business unit. Then we're going to get right into vSphere Integrated Containers. I'm going to give you a bit of a technical deep dive into some of the components that make up the engine. And then we'll spend, I'm hoping, more than half of this session on a demo in my live environment. As Jonas said, if you have any questions during the Q&A, please put them in the Q&A window. I will be monitoring it and pausing throughout so we can answer your questions as they appear. All right, so the Cloud Native Applications business unit at VMware is looking after a number of open source projects that relate to container management and other topics. You can see a number here. Some of them we're going to talk about today, like vSphere Integrated Containers Engine, Harbor, the open source registry that was recently accepted in the Cloud Native Computing Foundation as an open source project in their sandbox. So we're hoping to get even more contributions from the open source community on that one. And then a number of others like Hatchway that aims to bring transparent access to vSphere storage for container workloads. Admiral, that's also part of vSphere Integrated Containers, and it provides a lightweight management portal for your containers and your container hosts, as well as a host of others that you can see when you visit the VMware GitHub page. Today, we're going to focus on vSphere Integrated Containers. There's 3 main components of vSphere Integrated Containers. There's the engine component that we're going to focus on today. Then there's the container registry. Again, this is based on Project Harbor. It's an open source project at VMware. It provides a Docker-compatible container registry that provides a lot of the controls you need to run a container registry in an enterprise. So things like authentication against a company directory, built-in vulnerability scanning, built-in image signing, a lot of those controls that you need to run a container registry and integrated in an enterprise that's been operationalized for production. The last piece of the vSphere Integrated Containers is the management portal. And again, that's a lightweight management portal that we have that gives capabilities around managing your container host, your containers, building simple application configurations that are made up of more than one containers, so on and so forth. And all of this, of course, is built on top of the vSphere hypervisor. And as we're going to see, vSphere Integrated Containers engine is really built to take advantage of all of the underlying vSphere construct and allow you to provide a Docker native experience to your users while getting all the benefits from the tools and processes you've built over the years managing your vSphere infrastructure. If you're interested, here are some of the links to the actual GitHub repos for these projects. So Admiral, again, is the portal. Harbor is the registry. And then Vic itself is made up of 3 repositories. The main one is Vic. That's where all of the engine things that we're going to talk about today is built. Then we also have Vic UI. That's the repo that we have for the vSphere client HTML5 integration. And then Vic product is where we keep all of the tools and the scripts that we use to build the OVA. The OVA is used as a distribution mechanism for the officially supported versions of vSphere integrated containers, because while this is an open source project, it's available to all for free. vSphere customers have access to these official releases that they can deploy and get full support from VMware that's included in their vSphere Enterprise Plus and Robo Advanced support. So it's really a feature of vSphere, nothing else to purchase from that purpose, but also completely available and completely open in these GitHub repos that you see here. All right, I'm just going to do a very quick introduction to containers because when I'm going to talk about some of the problems we're trying to solve with Vic, it's going to help if we have a common understanding of containers, some of the benefits, but also some of the challenges they pose when you try to go from running them in production on your laptop, in development on your laptop, to pushing them in production. So to understand containers, it's good to look at the way we're doing things today. So today, if we have an application we need to run, we typically start with a standard Linux host that's running a standard Linux kernel. And then on top of it, we need to install a number of management and tools to make that machine useful. And this is what's often referred to as a distribution. So that Linux distribution gives you a number of basic libraries and tools to get up and running. And then once we have that distribution, on top of it, we can install the mid-tier, so the application middleware that we need to actually run the application. So that can be Apache, you could be curating some version of Tomcat server to run your Java application. And in that space, we're starting to see an emergence, well, not starting to see, there's a number of tools available out there to help you with configuration management. So tools like Puppet, Chef, Ansible that can help with making these deployments consistent and managing them over time. Then once I have all that, I can start deploying my application on top of that machine. And that's the way we've been doing things for a while. You're probably today using things like virtual machine templates, or maybe you're already using some configuration management tool to help with deploying this in a timely manner and in a consistent manner. But all of this has its own challenges. As you're aware, over time, maintaining these images in a consistent state, making sure that they haven't drifted from the original configuration that we put in there. These tend to be long-lived. There's some configuration management headaches as well. If my app process here, for example, app process 1 requires a certain version of a library, but my app process 2 requires a different version of that library, it can create some nightmares in terms of keeping that host up to date and patched and current. So with containers, containers really provide a way to reliably package an application with all of its dependencies. So we start with a similar Linux host that we had in the past, but in this case, we start with the same Linux kernel, standard Linux kernel, but what we deploy on top of this machine is a container engine. So we're using Docker as an example here, but there are a few others that are emerging as well. So you start with a Linux kernel, a lightweight Linux distribution that gives you a container engine, and then you can start deploying containers on top of that Linux host. So what's in a Docker container? Container is built from a container image. A container image is built from a container declaration file, or a Docker file in this example, that basically defines what goes into the container. So if we take a bit of a closer look, you can see that this particular container is built from a baseline Ubuntu image. And then from this image, I run a number of application installs to get those runtimes or those middlewares that we talked about before. So you can see here I'm installing Apache. I'm installing a number of patches just to make this ready to run. And then I define what port or service I want to expose out to the outside world. And at the end of the Docker file, I define my my container actual process that's going to run inside of my container. So here I'm running Apache with my user data and running that inside the container. So what this means is that I'm actually starting from this Ubuntu distribution. I'm installing all the tools that I need inside of the container to run my application. And then finally, I can run the actual process and run my application. So that means that I can very reliably and predictably package my application now with all of its dependencies. The other important aspect here is that Docker has created a very rich set of lifecycle management tools that allow you to create those containers, update them, run them. So, you know, that whole workflow of lifecycle management tools is a very important aspect and something I think that helped really drive the adoption of containers. Another interesting side effect is that it may not be a best practice to do this, but it allows you as well to start from different distributions of Linux as your sort of baseline in your containers to start building your containers and meet your application's requirements. So it's not necessarily a best practice to mix Linux distribution, although these things are isolated. You know, they use OS level isolation with this with these Linux containers. It's not necessarily a best practice, but it is a possibility, and it just goes to show that it's a way more flexible model for packaging applications and making sure that all of the dependencies are met and match that application over time. So you can understand why developers like containers. They're very portable. So a container that I build on my Mac laptop today, I can take this exact same container, drop it into my maybe my internal private cloud where I have a container engine. Maybe I drop it into Amazon EC2 where they're providing a container runtime. Anywhere you have a container runtime, you can take this image and move it. So it enables some very interesting things like moving from dev to test to prod, moving across different infrastructure, be it on-prem and off-prem. Containers are often seen as a sort of a stepping stone to cloud, and that's one of the reasons why. Containers are typically very fast to start because they're sitting on top of an OS that's already running, and they're basically only bringing up the application itself and its dependencies. They're very fast to start, and they're very lightweight. So again, I'm not packaging anything that I don't need. I'm just packaging the things I need to run my application. And lightweight, we also mean lightweight in terms of the management. As you saw in the example, it's fairly simple for me to get started and start building my own containers using a very easy to understand declarative format that just tells my container runtime what I need in terms of the container and the application and its requirements. If we look at what ops needs, though, you know, their needs are very different, and there's some problems with, not problems, but you know, some things with containers that we need to address and that we need to look at before we can think about moving them to production. Two that are very important are around networking and security. You know, container hosts have their own internal networking. They have this thing called a bridge network that allows containers to talk to one another and to talk to the host. That's kind of this obfuscated thing that lives inside of the host where it's very hard to get visibility. From a security standpoint, I can put a big bubble around my container host, but it's pretty hard. Although there's tools emerging now that allow you to do it, it's harder to get into the abstraction level of the container and have introspection at that level. Another problem that is common is data persistence. So containers, as I showed you, they're immutable. They're non-persistent. So you never patch a running container. You basically create a new version of the container image, kill the old running container, and instantiate a new one. So that means that if you want to persist data, if you have data that needs to survive the life cycle of the container, it has to live outside of the container itself. So there's many ways to do that, and we're going to see how we're addressing that with Vic Engine. Finally, consistent management. That's more of a day two operation consideration, but it's an important one, especially in larger enterprises. But not having to learn a whole new stack because you have this new category of applications that you want to run that are containerized, being able to leverage your existing tools, processes. That's another consideration for ops. And these are really some of the problems that we're trying to solve with Vic Engine by trying to bring all these benefits of portable containers, immutable containers, the very streamlined lifecycle workflow, but bring those to vSphere, where a lot of our customers already have a lot of know-how on how to manage it, how to secure it, and how to maintain it over time. So if we look at this from the standpoint of the provider versus the consumer, vSphere Integrated Containers sits right on top of your virtual infrastructure. You don't need to change anything in your virtual infrastructure to run it. You just basically, if you're using the open source version, you're running a command line called Vic Machine to create your virtual container host, and you're ready to go. And really from the provider standpoint, the provider is using all the tools that they have, that they know today for maintaining and using their virtual infrastructure. But what they're providing that's new is they're providing their developers or their end users with a Docker consumption model. So that ability to create for developers a Docker native experience where they can interact with the platform using a standard Docker CLI or Docker API. They don't have to learn any new tools. If they built anything that leverages the Docker API, it will work right away. So that Docker native experience, while allowing for operations to, again, have a vSphere native experience where they're using their familiar tools that they've developed over the years, and all that knowledge that they have on maintaining a vSphere infrastructure. So Vic installs on top of vSphere. You see NSX and vSAN here. They're not dependencies. If they're there, we have some integrations that allow us to bring additional benefits, but it's not a requirement. You can deploy this on a single ESXi server, and it should work. And then we have this concept of the virtual container host that I'm going to dive into, as well as these components that you see here, these three components that have a Linux kernel and a container application running on top of them. They're what we call container VMs, and we're going to talk about those and see how those are deployed and some of the benefits that they bring. So diving into the engine. So again, to understand how we do things differently with Vic Engine, it helps to look at the way that things are done normally. So if you're running containers today, chances are you're deploying a Linux VM on top of which you're installing a container engine. So again, we're using Docker engine here as the example. And then you give access to that VM to your developers and they start spinning up containers. So it's probably the way you're doing things today. If you're deploying containers today or supporting teams that are using containers in your environment, that's probably the way you're doing it. Deploying a Linux VM with a Docker engine, and then your developer goes in and start bringing up containers on top of it. And there's a number of issues with this, right? First of all, your containers, in terms of the resources they have access to, they're limited to whatever resources you gave that VM. So whether you're running 3 containers, as in the picture here, or you're running 300 containers, they're only getting as many resources as that VM has allocated. Then, because there's an additional layer of abstraction, between the VM or the hardware running the containers, you have limited visibility. It's very hard to understand what consumption in terms of resources this container has. It's very hard to understand what kind of network flows are coming in and out of this container. Again, you can see what's happening globally in that Docker host, but it's pretty hard to see individually for each of these containers what's going on. And similarly for security, it's hard to put policies and govern the way that each of these individual containers are talking to the outside world. So you could put a big firewall around this Docker host, but it's very hard to understand and see and put controls around how these containers are talking to one another, how they're talking to the host, and things like that. So what we did with vSphere Integrated Containers engine is that we took the engine out of the host. So we have our Vic engine that's running inside of its own VM, and we put this inside this VM inside of a resource pool. So we use the resource pool as, we use it for two things. We use it as a resource management construct, so it gives us a very flexible way of managing the resources that are available to this virtual container host. And two, it allows us to group together all of the container VMs that we spin up that belong to this container engine. So using the same building blocks that Docker uses, so we use the same Docker image, same format. You can pull Docker images from Docker Hub, and they'll work here. But using the same building blocks, what we do is, instead of using that Docker image and building a Linux container using a namespace, using a C group, we use those same building blocks, but instead we build a VM. So this is a very lightweight VM that we call a container VM. In terms of its management lifecycle, it's under the control of the Vic engine. It's a container VM. It's a full-fledged VM. It shows up in your vCenter inventory as a first-class citizen. We use a lightweight Linux kernel that's based on Photon OS to bootstrap the VM. And then once the VM is up and bootstrapped, we use the different layers of the Docker image to build a VMDK. We mount that VMDK in the container VM, and then we shroot and we run that entry point that I showed you before. So this is a very lightweight VM that's running just the application that's defined inside of your container image. So the container engine is running separately. If you spin up a different container, every container gets its own container VM. So you get all the benefits of the isolation, the well-recognized isolation that's provided by the virtual machine. And then, so you get, the facility of spinning up these images using your standard Docker workflows, but then you also get the benefits of the resource management that you get by running on top of a vSphere cluster, because all of a sudden each of these individual containers has access to all the resources in your vSphere cluster. I'm going to show you in the demo how we use DRS to actually make intelligent initial placement of these container VMs. And then they can move around with vMotion. DRS can kick in to rebalance the load, shake and restart them. So all those benefits that you know from your vSphere environment are brought to this world as well. So Vic engine, really quickly, it allows you to run Docker images as VMs in vSphere. So what that means is that we use the same building block, Docker client, Docker API, the same Docker image format, but we instantiate everything as a VM so that they're first-class citizen in your environment. You get full visibility. You can apply security policies the same way you apply them to your VMs today. It's a fully open source project. It's available on GitHub, as we see here. I talked about the Enterprise Plus and Robo Advanced. It says need here. You need it if you want to have support from VMware, but you're more than welcome to download this and run it if you want directly from the open source If you are a vSphere customer, I would encourage you to download the official releases, because then you can call your VMware support to get help. And it's a feature of vSphere. It takes advantage of all the other constructs that are in here. Container VMs we talked about a little bit. They're lightweight VMs that are under the control of our Vic engine. They mount the images as read-only. So again, all these characteristics of containers where they're immutable and I can bring them back to a known good state very easily. They're all present here. They have an ephemeral storage layer on top of it. We can also attach them to persistent volumes. So we're going to talk a little bit more about how that works, and I'm going to show it to you in the demo as well. But we use a tether process to allow the container VMs to be controlled by ESX and vCenter. This container VM, again, it's a first-class citizen, so it's connected to a port group. It's not connected to a sort of a virtual network that lives only inside of the container host, as in the native Docker model. This is connected to a real port group. So if you have any type of network flow monitoring tool, it'll pick up all the traffic coming in and out of this container VM. The virtual container host, that's a combination of the resource pool that we use to, again, group the container VMs and provide resource management, as well as one VM that we provision in there that gives you that Docker compatible endpoint, and that's the virtual container host VM. So it's Docker CLI compatible. The containers don't share the kernel. The control plane, so the Docker engine itself, the container engine itself, is running separate from the containers. So if you look at a lot of the security problems around containers that you need to solve, a lot of them have to do with isolating containers from one another, isolating containers from the host, hardening that host, and none of these apply here because every container is inside of its own VM. And the engine is running inside of its own VM. And then the engine itself is booting off of an ISO that's immutable as well. So it's pre-hardened, it's maintained by VMware, and it can't be tampered with. So basically, right out of the box fixes or addresses a lot of the security concerns that normally arise from running containers or wanting to run containers in production. That virtual container host, like I said, the resource pool contains a VM. That's the API endpoint. So that's the thing that speaks Docker. The Docker personality that you see here at the top actually speaks Docker. And then the port layer services, that's a layer that we have as part of the Vic architecture that actually translates these Docker commands and translates them into vSphere. So that's what allows us to take, your Docker run command and then tell vSphere, create the VM connected to this network. It also needs a persistent volume, so connected to this. Go create a VMDK on this data store, connected to it, so on and so forth. So at a high level, this is the architecture. The port layer provides that abstraction between the vSphere layer and the container runtime, and then the Docker personality is the thing that allows you to talk Docker and provide that Docker native experience to your end users. In terms of the packaging, there's the Vic Machine CLI that allows you to create the virtual container hosts. There's the appliance.iso, that's basically the ISO that we use to boot the virtual container host. And then the bootstrap ISO, that's the very lightweight ISO that we use to boot the container VMs, and that provides that just enough kernel. I think it sits at about 65 megs currently, the kernel image that we use to bootstrap the actual container image. Yeah. All right, so let me switch over to the live demo. I'm going to just take a quick pause. I don't see any questions in the Q&A.
Nope, no questions yet.
Okay. Let me switch over to my demo environment. So here I have a vSphere 6.5 environment. It's made up of a cluster of 3 ESX hosts. I've already created the virtual container host. So you can see here the virtual container host resource pool. So this is where I can go in and edit the resources that I want to make available to this container host. So by default, it's created as expandable and unlimited. But if you get a consumer that's using a lot of resources and you want to avoid problems with noisy neighbor type of problems, then you can go in here and put a limit to how many resources are available. And then inside of this virtual container host, we also have, like I said, one VM. It's the virtual container host API endpoint. So this is the thing that speaks Docker. When I configure my Docker client in a few minutes, I'm going to tell Docker client to point to this API endpoint instead of running on the local Docker engine. So as part of the integration, we provide you with the Docker API endpoint environment variables. This is basically the thing you would need to provide to your end user in order to configure their Docker client to speak to this endpoint. There's also a lightweight admin portal that we have here that gives you some basic information about the health of the container host, as well as access to the logs. So that's the engine. I mean, that's what this is. The process is you would download a build off of the open source page, and then you get a directory called Vic, and in here you have the Vic Machine command. Vic Machine command is available for Linux, for Mac, and for Windows. So whatever flavor you're running, you can run the Vic Machine command, and this Vic Machine command would allow you to create your container hosts. Now, if you're running the version that we have, not the open source engine, but the full Vic version that we have that we package for our vSphere customers, then you would have a few more options. So if you download the real version, you're actually downloading an OVA from the VMware website, and then it gives you this management portal that integrates into the PSC for authentication. So those of you familiar with vSphere will recognize the PSC integration. I think I made a typo. Did I make 2 typos? So this is this Admiral piece that I spoke about before that gives you a quick, that allows you to quickly manage your different container hosts, running containers, and it also has integration into the Harbor registry. So this is the Harbor registry here. So you can see I have 3 images that I put in my private registry, and you can see the built-in vulnerability scanning, as well as the image signing that's provided, and I can set security policies. But I'm not going to touch on that too much. I see a question in the Q&A. How easy is it to run and test Vic locally on a desktop? It's not that easy, but it's possible. The way you can do it is to download the free version of ESXi, run that inside of a virtual machine. So, if you have something like VMware Workstation or VMware Fusion on your Mac, you could run ESXi, and And yeah, that's all you need basically is one ESXi endpoint to run Vic. Of course, if you're running against a single ESXi, you're not going to get like the resource pool and all of the DRS goodness, but you can still get the experience of having access to that Docker API endpoint, spinning up containers, and the containers bringing up as VMs, as I showed you here.
So just to continue on there, you said you don't need a full vSphere cluster, just a single ESXi host to test this out, right? So you don't need vCenter, things like that.
No, you can run this against a single ESXi. It's really configuration for testing. And again, you're testing only the engine at that point, but it's absolutely a configuration. It's in our documentation, and it's something you can do. It's not a configuration we recommend to run workloads in production necessarily, but if you want to just have something up and running to test, that's a good way to do it. Here I'm running in a full lab with a cluster because I want to show the DRS capabilities, but I also have it running on Fusion on a single ESX on my machine. So that's a different way of running it.
Perfect, thank you. And thank you, David, for that question.
Okay, so back to Engine, because this is where we want to focus today. So this is the view of the vSphere admin. So as you can see, this is a full-fledged vSphere VM. We can see that it got connected to a certain number of networks. We can see that it's connected to some data store as well. So all these things are configured by the vSphere admin. So you maintain a lot of control as the vSphere admin on what resources will be available to consume via the Docker API. So again, if I look here, I can see that I have this Docker API endpoint. So again, this is the only thing I need. So if I switch over to more of a developer view, here I have a Linux workstation. I'm running a standard Docker client. I think this is version 1706. So this is Docker Community Edition client that I'm running. And then I already set my Docker host to talk to this remote endpoint that I have. So if you don't specify this Docker host, what's going to happen is Docker is going to try to talk to the local Docker engine. In this case, I want to talk to this remote Docker engine that's sitting in my data center, in my vSphere data center. So from here, I can run standard commands like docker info, for example. Docker info gives me information about the engine that's listening on the other end. So I can see that this answers just like I expect the Docker engine to answer. But if I look closely, I'm going to start to see some Vic-specific things. So you can see that I'm running the Vic 143 backend engine. You can see that my storage driver is the Vic driver, and a number of other things, right? You can see this VCH CPU limit, VCH memory limit. These are tied to the resource pool numbers that I showed you before. So what we're going to do to show you how this works is that I'm actually going to run a little script that I created. I'm just going to kick it off because it takes a few seconds to complete in this environment, because this is running nested ESX somewhere in a lab in California. So I'm just going to kick off the script, and then I'm going to quickly show you what the script does, and then we're going to go see how this translates into my vSphere environment. So this is a simple script I created, and it's just to show that you can easily build some simple orchestration around your containers. So what I'm doing here is I'm actually pulling an HTTPD image from public Docker Hub. So again, here I'm demonstrating that you can run regular Docker images against this. So I'm just pulling HTTPD from Docker Hub. I'm telling the script run 3 instances of HTTPD, expose port 80. So I want port 80 is what's running inside of my containers. And then what this is going to do is it's going to provide a load balancer for me that also listens on port 80. And then I set the number of names. You know, I'm just setting some prefix names for my containers as they come up, a prefix name for my load balancer. And I'm also telling it what external network I want to use. In this case, I'm using something that you can only do in vSphere integrated containers. I'm going to talk a little bit more about it once this is up. So very simple, you know, I'm just creating a basic load balancer configuration from the parameters that the user provided. I'm pulling my HTTPD image from Docker Hub. I'm pulling the HA proxy, which is an open source proxy you can get from Docker Hub as well. I'm creating the regular Docker network. So as you can see, I'm running normal Docker commands here. So I'm just creating what's called a user-defined bridge network. And this user-defined bridge network, the cool thing about it is that it has built-in name resolution. So remember, I gave all my web servers the name web. Well, I can reference them by name in my configuration, and the load balancer is going to be able to find them because this Docker user-defined bridge actually provides name resolution built in. Then I'm bringing up my 3 web instances. And finally, I'm bringing up my load balancer here at the end. And here I need to do it in a couple of steps because this load balancer is going to be dual homed. So I'm connecting a first network here. I'm connecting it to my routable network. I'm also connecting it to this user-defined bridge that I created. And then I'm copying that configuration that I created in the first step here. I'm copying it in the load balancer container, and finally I'm starting that container. And then once the script has finished executing, it's going to give me what IP my service is available at. So again, you know, a very simple example of how you can build orchestration on top of a deployment like this, and it kind of illustrates as well why this is so powerful and why developers might want to use it. As a side note, this script, as well as a few others, are available in the Vic product GitHub page. There's a folder in there called tutorials that has this script as well as a few others. So let's go back to here, see if it completed. Yeah, so the script completed. You can see service is available at 192, 168, 100, 133. So let's just make sure that it worked. So let me go in here. And you can see I have an Apache web server listening on the other end. So let's see in the vSphere what happened. So remember I created 3 web instances. So you can see them here. So each of these Apache web servers got created inside of its own VM. This is what we call the container VM. We can see that these got connected to this port group called the bridge port group. So we use a port group to mimic the Docker bridge with the big difference that because this is a real port group, you can actually monitor it using network flow monitoring tool and see all the flows in and out of this, even though this is, you know, technically an internal Docker network. Here, because of the way we provision, everything's a first-class citizen in your vSphere environment. Every container is a VM, and then every container is connected to a real vSphere network, so you can get full visibility. Here, for those who have a keen eye, you'll see that I'm using an NSX logical switch to back this bridge network. Again, this is something that's supported, but not a requirement. You can do this with a regular distributed port group on the cluster. We can see that this also is connected to a data store. I can monitor this the same way that I monitor any VM, so I can see what's going on from a performance standpoint in each of these individual web containers. So you can see a little spike here as it came up. The other thing I wanted to show you is that we also have some basic information in the portlet here. You can see the name of the container that's running, and also the image that's running inside of it. So this is an HTTPD image. The other thing I want to draw attention to is this ID here, or this weird hexadecimal number here. That's the unique Docker ID that's provided by Docker. So this is the thing that allows you to do easy correlation from the view you get here in vSphere. So you see this Docker ID 3E3. If I go here and I do a Docker PS to see my running containers, I'm going to be able to find this 3E3 very easily here. So I can easily correlate the view I get from vSphere with the view that my end user gets using Docker. So again, Docker native experience for your end user. They don't need to know that this is running on vSphere. They're running regular Docker commands and they're getting regular Docker instances getting run. But from the vSphere standpoint, this gives you a lot more flexibility. So I'm not changing the workflow. We talked about a little bit that workflow and how the lifecycle workflow is really is one of the reasons why Docker has gained so much adoption. So we're not touching that. We're leaving that as is, but we're enabling it in a way that for the vSphere administrators, you're getting a lot more security because every one of these containers now is isolated, leveraging that VM as a security boundary. And from a resource management standpoint, you can see that this Web 1 is on ESX3, this Web 2 is on ESX1, this Web 3 is on ESX2, so on and so forth. So we're using DRS to make an intelligent placement decision when these container VMs come up. And depending on the level of automation that DRS is configured with, these will get rebalanced over time as well. So all the container VMs that I created using this container host get grouped under this resource pool. And we're going to go look at this load balancer because this one's a little bit different. This one should be connected to 2 networks. So you can see that I have this connected to the bridge network. And one of the side effects of running containers as VMs and connecting them directly to port groups is that I can now connect the container directly to a routable port group. So that's what I'm doing here. I'm using this VM port group that I use for all of my VMs. This is a port group that's running DHCP. It's on a routable network. That's my 192.168 network. You see the IP that it got here. It also received an IP. Remember this, the user-defined bridge network that I told you about? Well, this is this 172.17 network. All these other ones are connected only to the 172.17 network, right? So they're all connected to this back-end network that's mimicking the Docker bridge. And then this load balancer is the only one that's dual homed and exposing the service to the outside world. So I'm using this external IP to expose the service to the outside world. So this is an interesting side effect because now I can run containers with, enabling things like unique IP per container without having to resort to an overlay or anything like that, because I can connect these containers directly to a routable port group. So that's kind of an interesting side effect of running containers as VMs. The other thing we have in here is the integration with the client. This is again something that you get with the OVA install or the official deployment install. But this is another view you get where you can manage your container hosts directly from the vSphere UI. You can create new container hosts as well. I told you you have the option of using that Vic Machine command line that I showed you briefly, but a much easier way to get started is to use this wizard that's going to walk you through every step of how to create your container host and provide you with hints along the way for what we expect at each step of this, so you can make the right decisions on how to map your vSphere resources. And then we pull the resources directly from your inventory so you can easily point and click, giving you that same type of experience that you have when you're creating VMs inside of here. So again, if you're getting started, probably recommend that you start with this because this kind of explains what each of these parameters mean and you can make the right decisions as you're creating your container host. Because the process of creating the container host is where you're mapping your vSphere resources for consumption through the Docker API. So you need to make the right decisions to A, meet your operational requirements, and B, meet the application requirements as well. The other view I have from here is I have a view of all the containers VMs that are running. You know, I can filter them by image type, and then from here I can look and be taken directly to the page for the individual container VM. I'm going to pause here. I don't see any questions in the Q&A yet. I'm going to pause here to see if there's any questions that anybody wants to come up with.
Yep, we got one from Eric Skinner here. Is it safe to assume this solution, so Vic, can be deployed onto an SDDC like VMware on AWS?
Not on VMC today, and the reason is that VMC is a managed service. So as a VMC customer, you only get you don't get admin access to vCenter, right? And when you're creating your container hosts here, you need to have admin access to vCenter to create the container hosts, not to run them, but to create them. You could probably manage to do it by no, not even. No, I don't think you can do it on VMC today. It's something we do have on the roadmap, though. You know, we tested this on vCloud Air, you know, before it moved to OVH, but this should work on any regular cloud provider where they give you sort of full access to vCenter. It should work, no problem. But for the VMC model, there's things on the engineering side that we need to figure out in terms of giving the Vic Machine create process just the right level of permissions to allow it to run it against, or to allow the end user to run it against a VMC managed vCenter. So that's a limitation we have today, but it's something that we're considering on the roadmap.
Great. I have one question here. So I've seen you show the UI here. You've shown the Vic command as well. So does Vic support all Docker commands?
Yes and no. The virtual container host, we designed it with the purpose of running containers in production. We designed it with the assumption that the containers are getting created somewhere else as part of our CI/CD process. So the VCH will not run things like Docker build or Docker push. What we have for that is we have something called the DCH that's part of vSphere integrated containers. So if I go back here, we have this native Docker host that you can actually deploy. Again, this is all documented in our documentation on GitHub. But we have this, it's part of the distribution, this DCH Photon. And what this is this actually allows you to run a full-fledged Docker host as a container. So you can bring this up using Docker run, DCH Photon, and then you get a full-fledged Docker host that allows you to run Docker build, Docker run. Docker run is supported, but Docker build and Docker push, for example. This plays really well in CI automation because no longer do you need to maintain these long-running long-running container hosts just for the purposes of building the image. Now, because this is provisioned as a container, it's ephemeral like a container. So I can bring it up just as part of my pipeline for the time of building the image and destroying it after. So it promotes two things. It promotes effective or efficient resource utilization in your vSphere clusters. And B, it provides, it avoids the snowflakes. A lot of the Linux container hosts that we're seeing within our accounts are becoming quickly snowflakes because, admins typically have to give shell access to developers to the container host, and then configuration drifts happens, and every container host is basically a snowflake. In this model, we can provision it ephemerally, predictably, this immutable image. This was born out of another open source project called Docker in Docker. It turned out that because we're doing containers as VMs, doing container in Vic, Docker in Vic was a lot simpler. So we included it as part of the product to address that use case where customers need to build the container images themselves. And again, this is something that's well documented in our GitHub.
Awesome.
All right, so we touched on a lot of these. The fact that we provision containers as VMs allows us to get all the benefits of the underlying vSphere infrastructure in terms of resource management, security, visibility, monitoring. You can leverage all of your existing tools. Yeah, so if you're interested to learn more, we have the official VMware page. We also have a hands-on lab. If you don't know the hands-on labs, they're completely free to use. You just need to sign up, and they're real live environments. You typically have a little guide that'll walk you through the basic functionality so you can learn about the product, but then you have a full live environment where you can play and experiment. And we have one specifically for vSphere integrated containers that we just refreshed for VMworld. And I see now on this slide that I have the wrong SKU actually. It should be 1930 and not 1830 because we refreshed it just for VMworld a few weeks back. And then again, the links to all of the various GitHub pages where you can visit us if you want to contribute. We're always looking for contributions in terms of improving the documentation. Anything like that is welcome. So with that, I think that's all I had, and we're right on time.
Yeah, so thanks so much, Patrick. There is one more link that I would like to add into the last page there, and that is for the Slack channel for Vic Engine. So yes. If you want to ask any questions, continue the conversations here, please join us over on the VMware Code Slack. If you haven't already registered there, head over to code.vmware.com, and I put that in the chat. Head over there, register, and then you will get a link so you can get added into the VMware Code Slack. And we have a channel there called Vic Engine. So please join us there and for more conversations. And Patrick, if I wanted to reach out to you on Twitter or somewhere else, where could I find you?
So on Twitter, I'm PDAIGLE. So that's my my first letter of my first name and my last name. And then I also monitor the VMware Code Slack, as can be seen here. It's part of the multiple Slack that I monitor, but I am on this VMware Code Slack, as well as some of the Vic developers are on here as well. Some of the GSS folks, that's our support people at VMware, are on here. So it's a great first place to get help and interact with other users. We have some very active users on here that are using Vic on a daily basis and helping others get started as well. So great place to get some interaction.
Excellent. Well, I want to thank you, Patrick, so much, and for this presentation. I hope everyone here has had a lot of fun listening to Patrick explain Vic and the Vic engine and how it works. I want to thank everyone that's been on the call today, on the webinar here. So thank you so much. And we do have more webinars coming up next week. We do have a CNCF webinar for Harbor. So please head over to cncf.io and register for that. And we do have another webinar coming up next week as well for vSphere CPI, the cloud provider interface. So please join us there. The recording of this will be available most likely later this afternoon or early tomorrow morning up on the VMware Cloud Native Apps YouTube channel. So please, yeah, take a look over there. With that, thank you so much, and we hope you have a great rest of your week. Bye.
Thanks, everyone. Bye-bye.